Hello guys, and today let's solve LeetCode problem 23, merge case sorted lists. And in this video I want to talk more about the merge sort algorithm rather than this problem, but we will use this algorithm to solve this problem. So in this problem we have an array of arrays, and these arrays are sorted in ascending order. And we need to output an array. No, it is actually linked lists, but yeah, got a bit confused because it's written like an array, but it doesn't matter. So, and our output should also be an linked list that is consisted with these numbers in ascending order. So the solution will be pretty straightforward, and we will use for that, as I said, merge sort. So let's take as an example this array. So now let me actually talk first how the merge sort is implemented. So let's take these arrays. Let's take these numbers of these arrays. So 3, 4, 2, and 6. So we don't need that. Let's remove it for a better view. So like that. So, and the algorithm works like that. It is implemented recursively. So on each step we are taking the right side of the array and the left side. Yeah, this is left, this is right. So, and we are splitting them like that. So on the first step we will take this half and this half. So 1, 4, 5, 1, and 3, 4, 2, 6. So like that we will have two arrays that are consist of these numbers, and we will proceed to split it. So this is our first split, then we will split these two and these two. So it will be 1 and 4 and 5 and 1. So like that. Split like that and like that. And also here 2, 6 and 3 and 4. And at the our edge case to return from the recursion is when the array will be of length 1. So the last iteration will be like that. So it will be 1 and 4 and 5, 1, 3, 4, 2, and 6. And it is a single value in that array. So how we will merge them? It is, I think you will have a clear understanding if I will show it once, and I think you will get the idea if you watch the previous video. So we will first merge this pair and go above, because that's how the recursion work. Not particularly this, like in general. So we will merge this half and this half. So like that. It will be, in this case, 1 and 4. Yes. And then we will merge this half. It will be 1 and 5. And I think right now most of you really get the idea. So, and you understand why do I have opened the merge two lists from the previous video, because you see, if we have the two arrays that are ordered in the ascending order, like that, and it doesn't really matter that these ones are sorted. They could be not sorted. It doesn't matter, because we are starting at the base case, and we merged it when two arrays with one value, and they are sorted in ascending order. So right now we can also merge this part, and when we will do that, we will get 1, 1, 4 and 5, because we can sort that pretty efficiently with like that, and go then emerge this half with this half, because this because this half will be also merged like that. I think I can skip this part and don't show it, because it is also like that. We will sort 2 and 6 and 3 and 4, and then merging it together will be 2, 3, 4 and 6, and at the end we will merge this and this, and we will get our sorted array. So let's actually implement it, and for that we will have a variable called length, because we will need the length in some places, and it is the length of our lists. So, and after that we will have a variable, not a variable, let's actually have our if statements. So if length is now, we will just return, now, because we don't need anything. And here, if the length is 1, we will return our list, so list now. And here we will have our variable mid to split it. It will be length divided by 2. This operation also rounds. And here we will have our left part that we should also split. So it will be lists, merge lists, so lists till the mid, and we will also have right that will go from the mid to the end. So right, like that, and after that we will return, and here we will need our function. Let's have it as a function, and let's declare it here. So yeah, a bit misaligned. Let's make it pretty, or maybe it won't even compiled or interpreted, because it is misaligned, and Python is white space case sensitive. So return our name of the function, and pass here our left and our right, so like that. And of course not now, of course none. Did I misspell it? Of course, I need to call it from self. And yes, there should be no self because it is not in a class. Let's run it again. And right now, yes, it works. Let's submit it. So yes, right now it passes, and the complexity of it, I don't know. Will it do it? Yes. Mesh sort is nlog k. I don't know how LeetCode is doing it, but it is right. It's a very optimized solution, and as you can see, it is really pretty straightforward and easy if you think about it, that it is marked as hard problem. So the only thing that we did, we wrote the recursion and we copy pasted the code from this easy problem. So it is like, I don't know, 6 lines of code. So yeah, but if we weren't implemented that way, it could be even more optimized, as we could use here a heap, or like I think it can be also done iteratively, so without the recursion, or maybe with quicksort. Maybe in the next video I will explain the quicksort, but the merge sort is also considered very clean and very performant. So if you found this helpful, please leave a comment, subscribe to my channel, and thank you for watching.